Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. This week, I chat with Awa, co-founder of Anoma and Namada. We talk about her background in crypto analytics, her shift to working on infrastructure and privacy tech, and how the Anoma project came to be. She also introduces us to Namada, a separate but related network. We go through all the various cryptographic pieces that their team has been developing, many of which have been presented at the Zk Summit, Zk Hack, and in our Zk study clubs. We then discuss how these fit into Namada and, in the future, into the Anoma protocol. But before we kick off, I just want to share an announcement from one of our partners on the latest Zk Summit, the Web3 Foundation. They are hosting an in-person event called Sub-Zero in Lisbon at the end of this month. It's a Polkadot developer conference. This year's edition will bring together the global Polkadot community and provide an open introduction to those looking to learn more about Substrate, Polkadot's framework for building custom blockchains. I've added the link in the show notes where you can learn more and apply. I also want to let you know that there's a new Zk Hack multi-week event coming up starting on November 22nd. If you haven't been to any of the previous ones, it's a series of workshops spread out over 4 weeks with puzzle hacking competitions. Be sure to sign up for our kickoff event and jump into Zk puzzle hacking and workshops with us. Now, Tanya will share a little bit about this week's sponsor.
Today's episode is sponsored by Aleo. Aleo is a new Layer 1 blockchain that achieves the programmability of Ethereum, the privacy of Zcash, and the scalability of a rollup. If you're interested in building private applications, then check out Aleo's programming language called Leo. Leo enables non-cryptographers to harness the power of ZKPs to deploy decentralized exchanges, hidden information games, regulated stablecoins, and more. Visit leo-lang.org to start building. That's leo-lang.org. You can also join Aleo's incentivized testnet 3 by downloading and running a Snark OS node. No sign-up is necessary to participate. For questions, join their Discord at aleo.org/discord. So thanks again, Aleo. And now, here's our episode.
So today I'm here with Awa, co-founder of Anoma and Namada. Welcome to the show, Awa.
Thanks for having me.
I'm very excited to be having you on the show. I've had 2 of your co-founders on. There's 3 of you who are co-founders of Anoma and Namada. I've had Christopher Goes years ago talking about IBC more, and Adrian Brink last year telling us about like Anoma, sort of the first time we talked about it. So yeah, it's great to sort of have you join as well. I do want to say right off the bat that I'm an investor in Anoma, long-standing, through Zk Validator. And I also like to consider Anoma this like a team I constantly partner on so many things. Like we've done Zk Summit, Zk Hack, you sponsored the show. And anyway, it's just really great to have you on. And I'm very excited to actually catch up, even for my own understanding. There's been so much that's happened since that last episode with Adrian in terms of cryptographic builds and new libraries and announcements. And I think what I want to do with this episode is generally like bring it all together. Before this episode, we talked about how you'd never been on the show, but actually, Awa, you have been on the show before. So you were on, this is such a funny episode. So I did this episode, the ZCon Zero, like combo episode where I interviewed 12 people. Yeah. So I did the same thing with Strad just recently. Like there were so many great people on that episode that it's just because we did such small interviews. I think a lot of people don't really remember. I clearly don't remember all of them.
I forgot. But yes, I was interviewed at ZCon Zero. I remember that, yeah.
Yes. But what I want to do with the beginning of this interview is definitely understand a little bit about your journey. Like what were you working on before and what led you to actually work on Anoma and Namada and the problems that you're trying to solve? And generally like working in the privacy space.
Yeah, so the way I got started with this entire decentralized space was, I guess, less common compared to everyone else you have on this show. Actually, my first job in the space was at Chainalysis. Maybe some listeners here do not know about Chainalysis, but actually Chainalysis knows a lot about all your listeners, for certain.
Yeah.
So it was a very interesting introduction to it. What I was doing there was that towards the end of my graduate thesis, I was looking for data sets to analyze. It was back then in ML. And I came into just a company called Chainalysis that were developing tools to de-anonymize blockchains. This is basically the business model. And I wrote a couple of papers on how you could use ML to de-anonymize Bitcoin. So it was a really cool intro to the space because it made it very clear how much privacy was lacking in the base layers and how much you could do by deploying some basic statistic analysis or not even very fancy tools or algorithms to like extract a lot of data about individuals and entities that were using blockchains. I kind of wish I could like sponsor people to internet analysis before they touch any blockchain, because I think then we'll want privacy much quicker, or a lot less people will be using this for serious things.
Wow. It was almost like that was your first foray in and a major eye opener. Like, it sounds like this also colored a lot of the work that you did after. Tell me, after you left Chainalysis, though, what did you do next?
So towards the end, I kind of realized that I started to follow more Ethereum. That's how I came across with Cosmos and Tendermint back then. And I kind of wanted to be more involved in the actual development of the protocols. This is because the thing that motivated me the most about technology, that really led me to choose to be more involved in layer ones, is that I'm into this entire space because I kind of want to bring in systems and applications that do not further exploitative paradigms that we currently have especially in Web 2. Like, we have all the systems that basically give a few parties a disproportionate amount of access and a disproportionate amount of power and leverage of like users' individual data or a bunch of other things. And I kind of wanted to pursue a path where I could actually start building things and contribute to building systems that can bring alternatives to these exploitative paradigms. So then I realized that doing data analysis and looking at analysis was probably not the most way to have a big impact. And then I saw that still the state of protocols was in very early stage. Like back then, proof of stake was still like a theoretical concept. Right?
What year are you talking here? 2017?
You're talking about towards the end of 2017, beginning of 2018, right?
I think that's when we met, right? Like, yes. I think it was right around that time at Full Node that we would have first crossed paths. Right. Had you left the company then, or were you sort of like in the process of leaving?
I was still part of Chainalysis. Didn't leave yet until I kind of started to be more involved with Cosmos. And then for Cosmos, I was just involved in like pretty limited capacity, part-time, and that's where I met Adrian and Chris, and then the history follows.
Cool. But before you did Anoma, you did have another project together, the three of you. Tell me a little bit about being a validator. Yeah.
The entire thing is that, so I met Adrian and Christopher at the Cosmos or Tendermint, and in summer 2018, Cosmos was supposed to launch, and it was not very clear whether there would be enough competent validators to operate the network at mainnet. And this was still, in summer 2018, proof of stake was still a very early concept.
Totally.
It was theoretically going to work. Like nowadays, it's completely given. All new chains that launch are following the standard of proof of stake. But back then, it was not so obvious, and there was definitely not a very developed landscape and ecosystem of different validators. So together, we kind of decided to start a validator called Cryptium Labs. This is how I also moved to Switzerland, and why we picked Switzerland as well. And the anecdote that maybe Adrian skipped is that actually we are the only validator that is kind of considered a national security critical for Switzerland.
Cool.
So like it is part of the critical infrastructure of a bunch of Swiss banks.
Wow.
So the story is that like one day Adrian was going to a data center, and then he ran into a few tanks that were just doing some kind of, some training and testing how they would defend this data center in case something happened.
Whoa. But wait, it wasn't data security just because of you guys were in the data center, was it? Like there might have been other things there as well.
It was because there are a bunch of national-wide critical financial infrastructure.
I see.
That also uses that data center.
Oh, cool.
And then there was just like the entire group was being defended and secured by the military.
Wow.
So that was like the anecdote. But anyways, Cryptium Labs, Proof of Stake Validator, it was actually the first organization or company that we started, the three of us. And it was a Proof of Stake Validator that focused a lot on security over liveness. Just there's a bunch of early things, those things mattered. Nowadays, everything is on AWS. And we were the few that actually ran as much physical infrastructure as possible.
Yeah.
So bare metal, use as much HSMs, physical HSMs as possible. And we focus on operating networks that we consider technically interesting and novel. So a lot of layer ones.
That was a very different time for the validator community, though. I mean, I've spoken to Brian Crane about that too, which is like back when it first started, there wasn't really a clear business model. Like it was just so unsure if this would be something that could be a business that would be sustainable. So a lot of the people doing it were kind of just experimenting, like trying it out, like seeing how it went. How was that? I mean, in your case, were you all still working somewhere else? Like I know Chris was still doing IBC research and stuff like that at the time.
That's right. Yeah. And Adrian was still part of Cosmos. Later on, he joined Web3 before being more involved. But I was working on it basically full time.
Okay.
So the end of Crypto Labs was just that over time, it was really cool to be part of like operating infrastructure and the networks of layer ones. But sometime in the middle, we kind of realized that we wanted to be more involved with more protocol research and also getting more into like some areas like cryptographies and large proofs. Like back then, I think 2019 was the Cambrian explosion of ZKPs, right? Mm-hmm. So by then, for example, specifically to that field, is when we started Metastate.
And I remember that. Like it was like, this is a validator, and yet there's this really crypto-heavy blog. I remember I'd always post it on ZK Mesh, which I'm going to plug right now, by the way. ZK Mesh is a monthly newsletter that's still out where we put like the latest research. I'll put a link to that if anyone wants it.
Like I remember ZK Mesh did feature some of the articles that we posted on Metastate's blog. This is the company name.
Yeah.
Those were, for example, Plunk by Hand was a very popular one.
Totally. But yeah, I remember that. And I remember thinking like, this is an interesting pivot sort of for a validator. I mean, around the same time I started ZK Validator actually. And we fully like leaned into like, we're just promoting, talking about, and like, championing this like new technology. But tell me kind of from Metastate to Heliax maybe, like what was that was Cryptium becoming Heliax or was Metastate becoming Heliax in a way?
So actually Cryptium was just a validator and it just stayed that way. Okay. We started Metastate as an independent company. The thesis behind Metastate was just that we're not very clear on ahead of time what would be the business model behind Metastate, but we kind of bet on the people who are able to write novel layer one protocols, build them and operate them and maintain them, plus that were knowledgeable among three particular fields, which were distributed systems and consensus, PLC, so programming languages, and cryptography, especially in the ZKPs, will be able to make money in the future, assuming that those four pillars were going to be crucial for any team that in the future will be, if all of this is going to replace the financial system, then a team that has this kind of knowledge and expertise will not have issues making any money. So that was like the story behind Metastate and our purpose with it.
And did it become Heliax, or did you kind of start something new with the like learnings from Metastate?
Actually, the team that was on Metastate towards the end of 2020, officially on the 1st of February, was the one that was brought to Helix.
Okay.
So I think you could consider that Metastate pivoted towards Helix. We started with a team of 15.
Cool. And that group, it was a research group, like you were creating content, you're building sort of like this knowledge base, talent base in a way. Like, were you building something then too? Were you already experimenting, or was it more like a research group?
No, we actually built all major protocol upgrades on Tezos.
Oh yeah, this is maybe something to mention because Tezos was a strong connecting point. You were really involved in that community after being involved in Cosmos, eh?
After, so I think it was more because actually Tezos was the first proof of stake network that launched.
Oh yeah, true.
They had a very unique, their own proof of stake model, but it did go live in summer 2018. So that's when we started Cryptium, and we kind of decided to just operate that to see how it goes.
Got it.
That's how we got connected to the Tezos ecosystem, and we did get some grants from the Tezos Foundation to build on to further some of the research that they were also interested in. Mm-hmm. So all the areas on PLTs, ZKPs, and consensus that we're doing, they were interested in as well. But at the same time, we also worked together with the core development team and build some of the major changes that upgraded life,
wow.
$3 billion worth of value.
Good experience.
On-chain governance process.
Damn.
Yeah.
That's
Yeah,
wild.
but this is just to show that, like, I think our background is more like, is actually very full stack in the sense of, you see a lot of teams nowadays that are stellar in cryptography. You see a lot of teams that are stellar in layer ones, and some that are really stellar in application. But I think what's very unique about Helix as a team is that we have like everything from operating networks from the validator side, so like writing, extending layer ones, so like application building, like so dApps and everything.
Interesting.
And this has also translated a lot into today's Helix, because we're building Helix as an organization that is vertically integrated. So we're not building only layer one, launch it and say, now go have fun, build applications and interfaces. We actually, see later with Namada, for example, it's not just the protocol and then the tooling and everything around the ecosystem. It's also being released with at least one end user interface, so people don't have to rely on the command line.
Got it. And actually, I think it's a really good moment for us to define these different groups that we keep kind of mentioning. So when I introduced you, you are the co-founder of Anoma and Namada. So we've mentioned this a little bit, but Helix. So Helix is a company full of great engineers with all of this experience. What is Anoma today? Just a note, like when I had Adrian on a year and a half ago, we talked about Anoma. So how do you define what Anoma actually is?
So Anoma is the name of the protocol.
Okay.
It is one of the protocols that we're building. The other one is Namada. It is also a protocol. So there is no company or organization.
Okay. Do they interact? Like, are they connected? Is Anoma going to be, I don't know, some protocol underpinning what Namada does?
So first, I would like to just give an updated definition of what Anoma is, just on a high level.
Sure.
Just to position the entire thing. So actually, Anoma is just new, like novel general architecture to how you build blockchains.
Okay.
We refer to it as a generation 3, so it's a general architecture. It has a lot of association with privacy, but it's actually not a privacy blockchain in that sense. It is just, on the privacy side, it allows you to expose really good privacy-preserving primitives for application developers. But the right way to think about Anoma is that it is just the next evolution in how you're going to build layer ones to later on support applications with different properties. So novel applications cannot build on existing blockchains, or the same applications but fully decentralized.
And then at the same time, though, like, would you then categorize this as something like Substrate? Is it the builder, or is it like the Cosmos SDK?
No. If we're back in 2015 and we only had Bitcoin protocols and cryptocurrency protocols, like we call this group as cryptable settlement. And then Vitalik came and said, I can try to do a few cool applications of Bitcoin, but honestly, it doesn't work. It is all clunky as fuck. And this is just not usable. So here I proposed Ethereum, which is just a new way of building blockchains. So Anoma, it is the same.
Okay.
But today, Anoma is just proposing a new way of thinking about how you build the base layer.
Okay.
On top of which you can build applications. But it is...
So is it sort of like the way Bitcoin goes from like UTXO to account model? Are you going from account model to like new account model, or like privacy account model?
No, so actually the right progression, I'm just going to tell you the entire evolution of protocols in a nutshell,
Okay.
I think, is that we look at the first generation marked by Bitcoin as scriptable settlement. So scriptable settlement is actually really good for building cryptocurrencies with different flavors and privacy guarantees. Like with that, you see Monero, Zcash, a bunch of cool stuff. What a lot of people don't know in history is that with Bitcoin script, you can actually build other dApps and applications like color coins, Namecoin, the Bitcoin stock exchange. However, the issue is that you can build it and it works, but the issue is that applications will always have trade-offs and they will always look clunky and hard to use. So actually, Vitalik speaks about this problem in the Ethereum white paper. And that gave the room for him to introduce like entire new paradigm, which is what we call programmable settlement. So it is adds more expressivity, and you're able to program more logic at the settlement layer. And this is what gives birth to better versions of Colorcoin, which is the modern ERC20, or to Namecoin, which is the modern ENS. Way more usable, way more widespread, right?
Yeah.
And it also gave birth to a new era of new applications that it was too hard to build on the scriptable server, or maybe impossible. And those are things like NFTs, DEXs, AMMs, NFT marketplaces, DAOs. A lot of very interesting applications that you see today. And then ever since Ethereum, if you look into all the layer ones that were launched ever since, we call them basically programmable settlement plus plus. And this is because if you look at them in essence, the model that they introduced for application developers is still the same. It's still this imperative model, smart contracts, call them differently, but it's the same. But they come with different improvements in some particular areas, like it's faster, it's more scalable in some areas, it is more private, comes with different consensus, different civil resistance mechanisms, switch from proof of work to proof of stake. But if you look at them and also the applications that are built today, they're basically the same. So this is why we consider everything ever since Ethereum launched as programmable settlement plus plus.
Okay. And what is Anoma doing different? And maybe you wanted to clarify that because does it use a sort of UTXO type model, but does it better?
That is actually not so important.
Okay.
The background to why Anoma is the third generation is that how we got to Anoma, right? How we got to today's architecture of Anoma. And it is because we looked at some of the most advanced applications in Ethereum world, but it generalizes to any other programmable settlement system applications, is that they all follow a very similar pattern. And then you will also see that it has a bunch of downsides, like a lot of centralization points. So every application in Ethereum, think of, for example, all the layer twos. Think of CalSwap, think of OpenSea, the NFT marketplace. They all follow the pattern where the user has an intent. So an intent is just a signed message that they send somehow to the application, right? The signed transaction or authorization. That intent is gathered by, at the moment, a lot of applications make this feasible by a single operator database that usually becomes centralization point. That does some kind of compute to output a state transition on Ethereum, and that gets finally settled on Ethereum. So this is like the common pattern of most interesting applications on Ethereum, that at the moment, the best you can do is to follow this thing where, okay, you have the single operator database that gathers the intents, does some compute. That becomes actually the centralization point and choke point. And it comes with all the issues and kind of becomes the regression point with this entire technology. But there are currently two paths where you either go for the DYDX approach, where you just launch layer one to decentralize just that part, right? It comes with a lot of complexity, but it is a easy way to fix today the problem. Or you go for the other approach where you are ready to operate a very large organization like Coinbase and everything. And I guess OpenSea might go for that approach as well. But the main point is that how does Anoma fit into all of this? And actually, this is the background of how we came to the conclusion of what do applications need before they need a blockchain. And the main point is that if you want to do counterparty discovery, so where any application that needs counterparty discovery, where you do not yet know who your other parties are and what it is you're settling with, this is needed for basically any application, including DEXs and marketplaces.
Does it affect your ability to do an intention the way you describe that? Because you don't know who your counterparty is?
So today there is no way of doing decentralized counterparty.
Okay.
Outside of you have always a trusted party where you're sending the intents and they're going to try to do that.
I see. And here you're thinking like an order book a little bit. Like you say, I want to buy this at this amount, and you're waiting for someone to sell it to you at that amount?
Not exactly. So I'm going to get that to those design principles in a bit. But the main point of Anoma and why we think of it as the third generation is primarily that it is one architecture. To think of it as like Ethereum, but it's just a different protocol on many levels in how it's constructed. And this protocol has the advantage that it allows you to do the centralized counterparty discovery. It supports intents, the centralized counterparty discovery, distributed solving, and multi-chain settlement. So it also has the settlement part.
So it's just like a different way of thinking about it. Decentralized counterparty discovery, like it's sort of introducing almost like a different paradigm on how you would then build applications on top of it.
Correct.
Like you'd have these different tools. Okay,
That's
now
right.
I have to ask, like, is Namada not using that too? Like, is it not using these principles, or is it just tackling a different problem?
So actually, Anoma is an architecture for applications.
Okay.
But we kind of realized that early this year. So the story of why we decided to actually release Namada sooner is because there are some parts of Anoma component-wise Think of consensus, think of Taiga, and there's some other components that were still in development. And there were also a lot of features that were already ready that we could just deploy it into an application or into a layer one that could provide a lot of utility today. Mm-hmm. And there are a lot of parts, like, for example, the base ledger, the validity predicate system, especially the MASP, the entire thing that allows multi-asset agnostic part. A lot of these things actually were ready, and we really wanted to launch Namada sooner, just because we need this. We need a protocol that allows you to gain privacy without caring about what assets you use as a monetary policy.
Okay.
Now more than ever, especially with the recent events.
Let me sort of rephrase what I think you're saying here is like you've been building, and we're going to talk about this, like a bunch of different cryptography pieces. We haven't always understood how they fit together when they've been released. Like,
that's right.
Great research papers, very interesting, but we're like, okay, why exactly are they doing that? So now what you're saying is you have a few of those pieces in a state where you could release something, but you don't necessarily have all the pieces you would need to build out full Anoma. Is this true?
Mm-hmm. As of today.
Okay, so is Namada sort of like your canary network then? Is it like your first and then there's going to be another one? Or
the thing about Namada is that I think the closest case in layer one's world is Polkadot with Kusama.
Okay.
But it is actually different because Namada is its own layer one with its own scoped feature set, which is layer one proof of stake protocol that provides interchain asset agnostic privacy. So that's the purpose of Namada. Mm-hmm. It did start from an early version of Anoma, so it does come with some features that developers, if they look closely, it's basically an introduction or like a stepping stone towards Anoma in the future. Okay. However, Namada is gonna just live as its own chain. It would not have an upgrade path necessarily to Anoma. Mm-hmm. However, it will be a more intuitive and more immediate introduction to a lot of concepts that later on will be useful to descend Anoma. Practically speaking, looking at how the landscape is today with users, especially with some aspects around interoperability, like cross-chain transfers and all these things, IBC and bridges, a lot of bridge exploits, I kind of feel like we're still in early stages, even with concepts that we've been talking about for years by now. Yeah. So I kind of feel like we need to launch a network as well where you prove that there are better designs for Ethereum bridges, trustless Ethereum bridges, and there are good ways of leveraging great protocols like ABC for applications you can get on other blockchains that you cannot get on the base chain. So I think of Namada as a more intuitive, immediate entry point to a lot of these concepts of interoperability, but also protocols that are asset agnostic. So it doesn't matter what the native assets are. It's more about the protocol provides you utility, and then you decide which assets want to benefit from privacy or want to live where.
And I guess and I think we're going to get into this a little bit later, but because it's a privacy-focused project and because it's like dealing in interoperability and privacy, you are trying to build up in a way like that shielded pool, the candidates, the participants, the assets that live in the sort of shielded environment, because the more that's in there, the less easy it is to figure out who's who. Is that also part of it? Did you feel like
this is part of Namada?
Yeah, is that why? But that's what I'm wondering. Like, did you sort of feel like if we don't start building this up, if we wait until everything's perfect and release it, like you're going to have to start then to build up those type of pools?
Actually, no, it's quite independent. It's like so if you need to take away two major features that Namada brings to the table today that no other protocols brought so far. The first one is just the idea that all assets share one anonymity set. This is enabled by the MASP plus 2 upgrades that include the convert circuit. Mm-hmm. And this allows you to have one shielded set for anything, including, doesn't matter what the denomination and the origin of the asset. So think of like in the shielded set, the native asset, tokens from Cosmos, tokens from Osmosis, from Ethereum, NFTs, they all will be part of the same set. So this what means is that the anonymity sets will not be weakened or fragmented. And then the privacy guarantees are going to be the same for all assets. Because the issue that you have with when you do not have something like unified shielded set is that if your asset has very low transactional volume, it is actually quite trivial to de-anonymize it by just monitoring the entries and exits. So anonymity is very small. But if all assets share the same, then an NFT that has low volume looks the same as a transaction that pays gas fees.
Yeah. Although it's always at the movement outside of the shielded environment that becomes the problem.
That's correct.
Yeah.
So this is the downside would be just that the point to the shielded set to the Namada, that will still be transparent. And then if the origin chain is transparent, which is the case for most layer ones, then that also becomes a place where observers can get a lot of information.
Mm-hmm.
But if you interact within the shielded set, so as soon as you make it to the shielded set, people will not be able to connect it once it exits, unless you do some kind of a usability error or you send it to the same account on Ethereum or something like that.
Mm-hmm.
So that linkability is broken. And as long as you are within the shielded set, which you can also just use to do any kind of transactions with all your assets in the shielded set, then the transaction graph will just be removed.
Do you imagine actually any computation happening within that space, though, in Namada?
As in just like arbitrary computation?
Yeah. Or is it more for the transfer, more for the pool?
So it is possible, actually. Some interesting application that we have been experimenting with recently, and this was inspired by a conversation that Christopher Goes had with Dev Oya from Osmosis, is that actually Namada as a protocol, and this is, we're not releasing this with version 1, but this is really cool, and we could do this, is that you can actually use Namada as front end to create shielded actions on other networks.
Ooh, because it's IBC enabled, maybe? Because
it's IBC enabled. You have the shielded pool, the assets are already there. There's no linkability there's going to be, so for example, and this is how you work with Osmosis. The way you would use this is that imagine that you want to do a trade on Osmosis, and Osmosis is a transparent chain. So everything that happens there is kept transparent. But what you can do is via Namada, the shielded pool, you can authorize an action of trade those two assets on Osmosis. And then this package gets transmitted over IVC to Osmosis. That trade happens and it gets back to the shielded pool.
Just the info that it happened, just like a message that it has happened, or some sort of token?
In this case, it would be if you, for example, the tokens, the initial token, say a shielded DAI on Namada wants to be swapped for Osmo on Osmosis, then the shielded DAI is sent from Namada to Osmosis via, in this case, there's Osmosis support. Let's think of Ethereum then. Because I'm not sure if Osmosis supports DAI. But anyways, you want to try DAI for USDC. So you have already in a pre-step hold DAI on Namada, and this is in the shielded set, so it's fully private. With that account, you authorize a trade on Ethereum. So there's a DEX application on Ethereum that allows you to trade DAI for USDC. But you trigger that action by sending the message on Namada that is being transmitted via the trustless Ethereum bridge that we built. And that triggers the action on Ethereum. Then that results in the USDC that you send back to your account in the shielded pool.
And it gets shielded again on that return, but nobody knows kind of the...
There's no linkability. Even if you get, you can see how much USDC is being swapped for DAI on Ethereum. That's transparent. And you can also see that there's some USDC being moved over the bridge to Namada, going to the shielded step. But that's it. This is a really cool application you can build using Namada. Just more to answer your question of, at the moment, we don't think we're going to make, you can deploy validity predicates in Namada, but I think the main purpose is to focus on in-the-chain asset agnostic privacy. So start with getting people used to the idea that assets can be decoupled from the protocols. You can get privacy without having to buy into the monetary policy. You can pay for your milk privately, even if you know not price in milk using ZEC or Bitcoin, no matter how much we love ZEC.
Yeah, fair. One thing we sort of hinted at, but we didn't go through yet, is the different pieces of cryptography that have been developed. And I kind of want to ask you as we go through this, which parts are in Namada and which, maybe all of them are, but, and also go a little bit into them.
Not all of them are.
Oh, not all of them are. Okay.
Yeah.
So I want to start with one vampire, Joshua Fitzgerald. I think that's how you say his name, right?
Yes.
Okay. Joshua Fitzgerald had presented this at ZK Summit 7 in Amsterdam. And I remember because there's a lot of awesome names that come out of the Anoma, Namada.
Yes,
and so
there's a reason why we name some components of Artis, and Vampire is definitely one that's going to keep its name.
Okay. So vampire, let's talk about what that is. So it's a language, right? And I kind of wondered, like, is it a DSL for writing circuits?
It is not exactly. So a way we can look at this, and then some people from compilers and programming languages might kill me because it depends of like which abstraction you take from what part.
Okay.
But you, on one hand, have DSLs and higher level languages through which you can write circuits.
Yeah.
That's it. So think of, for example, Socrates, think of Circom, like a lot of high-level languages and DSLs. I think Leo will still be, from Aleo, will also be part of this category.
Okay.
And then you have in-the-end proof systems, like Plonk, RISC-V, etc. And in the middle sits Vampire. So Vampire is the intermediate representation that allows you to basically transform the higher-level languages and DSLs into something that any proof system can understand.
So it's not native just to the kind of circuits that you're using then?
No.
Okay.
So Vampire, and this is why we wanted to have its own name, its own memes and brand, is completely agnostic.
Okay.
So we build it in a way as like, we thought that it would be really high leverage to bring in this part of the entire tooling for writing circuits in ZKP world, because there is just no standard. And by having this, it will allow us to basically make all higher level languages be able to compile down to different proof systems, independent of what proof systems are available today and in the future. So it is completely intended to be a kind of standard, but a neutral tool that all ecosystems, languages, and builders can fully benefit from.
Got it. Do you have a DSL as well? Or would you imagine people writing, I don't know if they have to, but if they're trying to write the circuits in your system, would they then use a different DSL? Could they use Leo and Vampire?
So we are for the full like vertical integration for, just because applications on Anoma don't look the same as applications on programmable settlement architectures.
Okay.
We actually are building a high level language called JUVIX. I think you guys have spoken about this on a different podcast.
Yes.
It didn't make a lot of sense, but the way JUVIX integrates is JUVIX is a high-level language for writing applications on Anoma.
I see.
So it's for all kinds of applications, ones that handle private state or not private state, or like good transparent state.
So you would write in JUVIX and then Vampire would convert it, or would you not need
That's
Vampire?
Right.
Oh, you do need
No,
it.
you would. It's integrated with Vampire. Okay. So if you want to write certain applications that require, for example, custom circuits, you will be able to do that directly on JUVIX as a higher level language. Then it goes for Vampire, and then it gets like compiled onto the corresponding proof system as the application needs.
The next thing I want to ask about is Taiga. I actually have the name and I have no notes because I don't know anything about it. What is Taiga?
Yeah. So Taiga is actually the unified execution environment of Anoma. Think of it as like the state machine of Anoma.
Does Namada have that or not?
No, Namada does not come with Taiga.
Okay. So Taiga is a Anoma only. Actually, going back, JUVIX would be used for and Vampire. Would that be for both Anoma and Namada?
So for Namada, we actually don't need it because the circuit has been written. It's the MASP circuit.
Okay.
And we just have been upgrading it. We didn't use the tools for this. Parts of it, I often compare to Zexy and very Zexy.
Okay.
So just a little bit background story of why Taiga and how it relates to Anoma and why it's specific to Anoma's architecture. So Anoma's architecture has this unique design principle, which is it is intent-centric. So users do not sign transactions. Users sign which end state they will be happy with.
Okay.
And that end state can be like a fixed value, it can be ranges, can be whatever, but they do not pre-authorize an execution trace, which is what you do with Ethereum programmable settlement architectures. So they only sign for, I'm happy with a state where I have minus 1,000 ETH and plus 1 Bitcoin. This is what an intent is.
It's not derivatives, though, is it? Because that idea of the range and the wish, it's often like, I just think of derivatives as like a bet on the future, it hitting a certain moment and then something happens.
You can totally build applications like that using the intent system. It's actually going to be much better to use intent system than how currently some of these derivative marketplaces and applications are built.
Yeah.
But the main point is that is like a big part of how we designed Anoma. And there is no other protocol that is intent-based at the moment.
Oh, interesting.
And how that relates to Taiga is that, so we want intents to be able to be fully private, also fully transparent, depending on the application. And we look at it as like when you define an intent, if it's fully transparent, then this is just WASM code. It gets executed against WASM. You don't need fancy cryptography for that. But there will be applications which will require different privacy levels for the same application. So at the moment, with Taiga, we'll be able to support transparent, shielded, and in the future, private intents. The transparent intents are just like, you can read what the contents are.
Yeah.
With the shielded intents, the who is kept private,
Okay.
but the what is kept transparent.
Okay.
And this is the best we can do with the ZK piece at the moment.
But you just said that this private one, is there one where both are kept private or no?
That's right. But that relies on some fancy fully homomorphic encryption. Okay. And we're looking into how long it will take until that is actually usable in the system.
Okay.
But there's actually a lot of things you can already build with combining transparent and shielded state. And that relates to Taiga. So Taiga is able to basically take intents, no matter what part is transparent, shielded, or private, and then execute those. So the background of Taiga is not Ethereum is fully transparent, let's make it fully private or fully shielded. The background of Taiga is what do application builders need? And for some applications like a DAO, you will need parts of it to be transparent. Think of, for example, the results of the tallying of a latest vote, but parts of it to be fully private, like, for example, the individual's votes, they don't need to be transparent.
Interesting. Okay, I want to keep moving on to another project, Fervio, a DKG protocol.
Yes.
Where does that fit in? And is it in Anoma and Namada or only Anoma?
This can be in both.
Okay.
Yeah. So on Anoma, and this relates as well to this entire thing about architecture, Fervio is just a mechanism that the protocol exposes to application builders that makes it really easy to do programmable batching and a bunch of other properties. Like, for example, the threshold decryption scheme just removes the ability for validators, observers of the mempool, the transaction mempool, to basically do MEV or front running because they gain access to that information ahead of time. So Fervio on Anoma is two things. The thing that removes the ability for validators to do MEV or people who observe the transaction mempool. Here, MEV will refer to the MEV that you can get by gaining access to information ahead of others. So like this informational asymmetry. And the other part is that it allows you to do a bunch of cool things like, say, for an application, I want a batch to be this many blocks. This is cool for building applications that allow you to, for example, cow swap on Anoma benefits a lot from batches. Any application where you want to gather, for example, votes, or you want to gather bits from an auction, benefits from this kind of batching where you're going to keep the intents from the users encrypted on the blockchain, but encrypted, and they're only going to get decrypted at the same time, depending on how long the batch is. The only implementation that I know of that's closest to be released on Aleo 1 is Fervio, which is our implementation. And the paper was released this year. It was a collaboration between Joe and Dev.
Okay.
But we were the team. Actually, Fervio was started at Metastate and not at Helix. And we just continued building it. So to my knowledge, it's the only implementation of this kind of scheme that allows you to prevent MEV from validators and observers of the transaction mempool.
So how built is that? Like you're saying it's already going to be used in Namada. Is it finished?
So Anoma's going to complete that, but Namada, we are probably going to leave it out for a protocol upgrade for Namada after mainnet. This is mostly not because Fervio is not ready as a mechanism. It's actually because the mechanism is implemented on very closely with consensus. And there is a part on Namada that relies on AVCI. So this is the main core stack that is not ready. And so we were thinking of just deploying Fervio in a future protocol upgrade of Namada.
So you talked about batching and helping prevent MEV or change MEV basically. But first of all, what is it and how is it working in this context?
Right. The intuition is the following. So when you have transactions, they all go to the mempool, right? So far, all transactions are just transparent. Like anyone who just takes a look into the current mempools of any blockchain, they can see a lot of stuff in there. And that information can be front run. So like, for example, before you craft a block, then you look into like what transactions are available, reorder them in the way that you benefit to you the most and everything, right? So the way Fairview removes that ability is that transactions, before they make it into the mempool, they are encrypted against validators' public keys.
What you're talking, I mean, because I talked about this with Dave and Sunny in our interview on osmosis. We talked about this decryption, and I sort of understood all of that. But why are we using the term DKG for this? Because, like, to me, that distributed key generation, like, it's breaking up a key into multiple things, right? So, like, this is where I get kind of confused. Like,
this is just a component in the protocol, and this is closest to DKG protocols, but I wouldn't know why we're using this otherwise. So like Fairview has like two parts. Like one part is the DKG protocol part, and the other part is the threshold decryption part.
Oh, I see. Okay. There's something in the technique maybe that's using.
Yeah. But I'm sure like DKG is a family of protocols within cryptography that's not only used. It's not specific to Fairview and from running protection and stuff like that.
Okay.
DKG protocols are also used in other schemes for other applications.
I see. You just mentioned a trustless bridge to Ethereum.
Right.
Are you doing work on bridges? Is this like, I mean, Chris, having worked on IBC, I feel like I think when I had him on last, we talked about like, what would private bridges look like? Very theoretical. But yeah, are you working on that? Is that part of the sort of strategy of Anoma and Namada to have that?
So the very first versions of Anoma will benefit from like users can like transfer their assets from other chains to Anoma, and then they'll just benefit from the kind of features and primitives that it exposes. With Namada, this is actually more straightforward. We actually need this because we're not presenting Namada as a chain that creates new assets. It's more about when you have assets that were created in other transparent chains, how do you retrofit privacy? How do you benefit from the privacy of Namada? Independent of what assets you want to hold, you want to use. So in order to make that possible, in today's world, for any chain that supports modern fast finality and BFT chains, like think of, for example, any chain that is built using the Cosmos SDK supports IBC. So that's compatible with the IBC protocol. And that is actually the most preferred design for how you do bridging, because it just like you do not have any trust assumptions, even on the real layers.
This is the cryptographic bridge straight up. Both sides have like clients.
Like you don't even need like fancy ZK bridge for any of this. You basically just have a like client on both sides. And that's it. So that would be the best. But sadly, not all chains that are used today with a lot of assets support fast finality. So an example for that is Ethereum. And the goal was that we really wanted to make privacy accessible for all the people who are using Ethereum and have holding different tokens, including NFTs on Ethereum. So we looked at the different propositions of like bridge designs, and there's a lot of things that Nomad XLR, there's a lot of bridge constructions out there. But we actually decided to build our own. This is a custom bridge design because we want to prioritize the security for the end user, the assurance for the people who use this bridge above everything else. And it actually doesn't come at a huge, like the transactions are still really fast. Like it doesn't really come on with a latency trade-off. So this bridge design on a high level, the way it works is that validators on Namada will also have to operate a full node on Ethereum.
I see. Is the reason that you decided to build your own a result of some of the hacks that happened in the last year? Was it sort of like instead of working with a partner that maybe you have a little bit less control over, you would want to build it yourself, or was it more just that efficiency or that customization that you wanted?
We would have made this decision regardless of the exploits. Exploits were predictable, to be honest, but the issues on a higher level, with the issue that you have when you use something like Nomad or XLR is that you do not have control of what happens in event of an exploit. You do not have any control of what happens in there. And these are usually operated by another entity. So that's another layer of security through which the users have to reason through. And if anything happens, how does the bug get fixed? How does it get upgraded? They can at any point add arbitrary controls or freeze the assets over the bridge. This just adds a lot more complexity to the end user and allows us to, like, it removes a lot of our ability to add extra security guarantees.
What do you have to build to actually build this? Like, what are you building?
Oh, the Ethereum bridge.
Yeah. Do you have to build an Ethereum, like something on the Ethereum side?
We have to deploy a bunch of smart contracts in Ethereum too.
Okay.
Yeah. And then the bridge protocol is a bunch of Rust code integrated with Namada, and we're gonna also use it later for Anoma.
Okay.
So once it's built, it's kind of cool. And this design is actually generalizable to bridge into other protocols. So I think the design is actually very similar to, we proposed, you may not know this, we actually proposed a bridge to Zcash.
Oh, yeah.
It was published on Zcash Governance and Zcash Forum, something like that.
I think Chris mentioned this at the ZK Summit 8, actually.
Yeah.
Who also gave a talk. I'll also link that in the show notes and stuff. But
Cool.
Okay, so they'd have to build it, though, in that case, right? Like, they'd have to build the bridge part.
We could build it ourselves.
Or you could build it yourself. But in their case, there's no smart contract platform, so it's not like you can just trustlessly deploy it.
Actually, that's a good point. I think for Zcash, it would be a little bit different. But for example, for any other chain that is programmable settlement but does not support IBC, then we could build something very similar to what we built for Ethereum.
Interesting.
Just enable the bridge.
In the case of the Ethereum one, are you acting then as a bit of a rollup? Are you like a privacy rollup? I love those words keep blending together.
Once shielded actions are enabled, it's basically like a shielded rollup.
Okay.
But it's not, it actually provides you privacy. It's not like a Zcash rollup in the sense of, I think Zcash rollups actually provide you a lot of scalability, but it's not so much privacy.
This is now leading me to also like digging more into Namada, and that's what I want to do next, because I want to talk about the multi-asset shielded pool and Namada and the rollout and all that stuff. But like now I'm curious, like you would sort of mention that it won't have, or like Anoma is the whole thing, consensus, execution, all of that. Does Namada have its own consensus?
Namada uses just modern BFT, kind of in consensus.
Okay.
It does use a really novel proof of stake mechanism. So it comes with a bunch of innovations around, for example, how the fees are distributed. It follows an advanced version of the F1 fee distribution model. It allows you to, when you receive proof of stake rewards, you do not have to like withdraw them and then restake them. That creates a lot of transaction spam. It just like, the protocol just like auto compounds it, unless you want to unbond them and then do something with it.
Okay, but there will be a full validator set for Namada.
Oh yeah, it's a layer one.
Okay, so then that way it's maybe a little different than some of the rollups, which are relying on Ethereum as their like shared security. In this case, it isn't.
Namada is layer one, but with a specific purpose. But Anoma is more a general architecture for building dApps. However, it is one architecture where it is agnostic to how you deploy it. So what we're building is the layer one part, and we're going to aim to deploy the layer one. But you can actually leverage Anoma as a layer 1.5 or leverage Anoma as a layer 2 on Ethereum, for example.
Do you have to just strip out? You don't need the consensus then?
No, you don't have to strip out anything. You just can it really depends on like what it is the application wants. So layer one would be just an intent would just start and then die at the end. Finish, be finalized and settle on Anoma, right? Fully on-chain. From beginning, from the intent until it makes it to consensus and is fully written in ledger. So that would be Anoma's layer one. Anoma's layer 1.5 is, think of it as, if you want an application like OpenSea, Gitcoin, CowSwap, you want to decentralize a very specific component, like in the case of layer 2 is the sequencer. That's usually what's centralized. In the case of CowSwap is you want to make the solvers permissionless, so you don't want to be the party, the whitelist solvers. In the case of OpenSea, you want to decentralize the entire part of counterparty discovery, how like trades, which trades are made and matched. In the case of Gitcoin, you want to decentralize a lot of things because at the moment, the sad thing about programmable settlement is that really cool applications like crowdfunding funding, just what Gitcoin offers. A big part of it happens off-band, and only the final payments from the multisig get settled in Ethereum, right? That's a shame for like such a beautiful application. So in the case of Gitcoin, you will be able to build QF, but fully decentralized. So if your applications that you just want to decentralize a certain part or benefit from Anoma for a specific component of your application, then the way you would use this is that you use Anoma until it creates a transaction for Ethereum. And then that transaction makes it so Ethereum gets settled there via the Ethereum bridge. So that would be Anoma's layer 1.5.
Okay. Going to Anoma as layer 2. But then do you still, like, because I always think of L2s as not, I mean, I know they have like committees and sequencers and stuff like that, but like they don't need the full validator sets, right?
Right. So L2s only make sense if you want to rent Ethereum security. In the case of Anoma's layer 1.5, the transaction, it still gets settled on Ethereum. But if you wanted to rent Ethereum security, what that means is that you trust Ethereum's validators or miners more than you trust other chains. And Anoma as a layer 2 in Ethereum, the way it will look like is that it comes with a verifier of the entire state transition that happened on Anoma. But that only makes sense for if you want to rent Ethereum security. Like, I think there's a lot of confusion around what L2s are for and what they really give you. And I think that the most compelling case for applications Anoma and why Anoma will make sense on layer 2 is really if you wanted to get the extra security guarantees of Ethereum to verify that the state is actually valid.
Okay.
But you can do that.
All right. I want to do a little bit more on Namada. I mean, we've definitely talked a lot about the pieces that are making up Namada, but the part we didn't go that deep into yet is the multi-asset shielded pool, MASP. I mean, I guess we did talk about it maybe early on, but like I think that's the thing that I think people are going to be able to play with already, and we can talk maybe a bit about like the values and like the ideas that it's trying to actually promote by existing. And I think that was like, if I think back to the earlier episode I did with Adrian, I think that was the primary thing that we talked about. It was this multi-asset, the bartering system.
I listened to that episode and I thought, wow, Adrian basically pitched Namada, just like back then. But yes, the bartering applications, entire things that he mentioned today would just be example applications you can build using Anoma. But this entire asset agnostic world, multi-chain world with privacy, that is completely brought up to you with Namada.
All right, so let's talk a little bit about this multi-asset shielded pool. What is that? I know, and like we're going to define it now, but it's kind of already been defined in the episode. But like, what does that look like for a user?
So the multi-asset shielded pool is cryptography-wise, it is a custom circuit. And it has been upgraded a couple of times to enable a bunch of other features on it.
And this is based on Sapling, right? This is a custom...
Yes, the initial version, like the initial code base was Sapling.
Okay.
And then we just customized it 2 more times, at least. On one hand, what it means for the user is that when you make shielded transfers on Namada, all these assets will be sharing the same shielded set. It is this analogous to anonymity set. So when you make a shielded transfer with the NAND native token or with a CryptoKitty or with DAI, USDC, with Atoms or Osmo, it will all look indistinguishable from like any other transaction. And this is an important property so that you do not lose privacy guarantees in case you are transacting with an asset that is very unique or has low volume. So, for example, some NFTs, there's just so many of them. Or they're pretty unique, actually. So in those cases, one transfer in the multi-asset shielded pool, in the shielded set, actually benefits from the same privacy guarantees as any other transfer.
Having watched and I'm going to add this in the show notes, but I watched Chris's talk at CK Summit 8, and there he kind of talked about like the way that you define these different objects in the multi-asset shielded pool is just by you have basically a new category of like type of token.
Oh yeah, that's the technicality of how the circuit works.
But what I don't understand is with an NFT, is each one a unique token? Or what if it's an NFT in a set? Because if you think about it, you need a price, like a floor price for the set in a way. I got confused on that one.
So the way this may be the unintuitive part, is like actually within the shielded set, there is a UTXO model that keeps track of the assets, but it doesn't care about the denominations of the assets. So the asset type part is like a big change in the MSP.
And I think another thing that kind of came to my mind, and this is sort of it speaks to the same question though. It's like the oracle, like how do you define prices of these different assets that are coming into this space? Like if there's a full marketplace within it and things are being swapped and intentions like...
Oh, so you cannot actually do anything further than transferring in the shielded set. So it is not...
not a DEX. There's no... Okay.
No, just for transfers, just a shielded set. One unified one that is shared among any kind of asset.
I see. So this is really like, because, okay, so you would move an asset maybe from Ethereum over the trustless bridge into Namada. You could move lots of things into it. You could transfer them in that space to other people, I guess.
Yes.
Or to other wallets of yours.
Yeah.
And then you could bring it back out. There's no price exchange. And this is maybe where this is, then you don't need an oracle. That's fine.
Yeah.
Then actually the asset type, like maybe this is a detail here, but like are asset types each kind of like ERC20?
It doesn't matter which asset types you send there.
But it's more the question, like, does DAI have an asset type associated with it that all DAI would use? Or is it like it always has like a new value? Every time something new is sent in, it has a new value.
I'm not sure, but I'm also not sure it matters.
Okay.
Yeah.
Fair. Well, I guess it's something that I can ask Chris at some point. So everything we've talked about though so far, this is still like, I think the distinction of Namada is there's multiple assets that can be used. But what else, like, is there any other innovation that's coming along with such a development? Because right now it sort of sounds a little bit like solutions we've already seen where you just like move things into a private space and then move them around. Is there anything else that you like that's kind of coming with Namada that we can look out for?
Mm-hmm. So something that is pretty exciting about Namada is that users can get rewarded for using shielded transactions over transparent ones. And this is in alignment with our vision of the other tagline of Namada is privacy as a public good. The way we look at philosophically at the shielded set is that privacy is actually not a feature. It is more of a public good that it is non-excludable, so nobody should be able to be prevented from accessing privacy features. And on the other hand, it is also anti-rivalry. So like the more people actually use and contribute to the shielded set, the more privacy guarantees individuals get. So how does Namada fund privacy as a public good? It leverages some mechanisms in the MSP that allows that enable shield pool incentives. So a portion of the protocol inflation is actually directed to fund shielded transfers. And it is calculated based on how effectively you're contributing to the shielded set. So it is not made to encourage spamming. And the rewards are calculated based on which assets are sent to the shielded set and also how long it has stayed there. Are
some assets going to be better rewarded than others?
That's to be determined. Okay. But definitely the MSP is programmed in a way where we can determine like what is rewarded based on what parameters.
Cool. Is there also sort of like a strategy to expand the shielded set or like use bridges into other privacy networks?
The way I look at this is that independent of what assets you like and then which layer ones they come from, they can all be part of the same set. So on one hand, by diversity, it allows you to create more larger sets, even if you do not necessarily like the same kind of assets. So that's one way of looking at how you expand the set. But then a future next step is that actually privacy sets or shielded sets are competitive. So if there is one that has this really large anonymity set, then a new one that has spawned is going to have a hard time competing.
Totally.
And it has this network effect of you're going to get privacy guarantees in the larger set. So there's no really an incentive to go to the small one over this one. And this is where our research into private bridging and private IBC comes into play, because we would like to enable shielded sets to be able to live in different layer ones, depending on like which security model they prefer, what the users want to do, but without actually having this competitive effect on the shielded set. So if we enable private bridges and private IBC, then all shielded sets would actually be shared, independent of like which layer one they're part of.
But that's that sort of challenge of these privacy, the sort of shielded pools or like anonymity sets is like, if you were to create a lot of these privacy networks that don't connect, then each one is going to have to bootstrap that on top of whatever, like a validator set and a user base and all these things. So yeah, and like the smaller number in the anonymity set, the less anonymous people are.
Yes.
Because if there's 4 people and they're doing things, you can kind of figure out who those 4 might be.
Mm-hmm. And actually, this all comes into play of like, to the initial question, Anna, you asked me about like, how does Anoma and Namada relate? And we're trying to like get to that, but we haven't really answered that, right? So actually, Anoma's long-term vision is that we strive for a multi-chain world where even Anoma instances and Namada instances scale fractally. And we want to push for this vision that we call homogeneous architecture and heterogeneous security. Mm-hmm. This means that protocols and applications become just standard, and they can be ported across different security domains that are not standard. This is why heterogeneous security. Because in a world where applications and the base protocols are the same everywhere, the only thing that is going to matter is going to be who do you trust. So what is the token? What is the governance around this? And who is the validator set or the miners? That is what composes the security domain. And it depends on the application and on the user. But I can totally see a world where for financial transactions, some people might trust more the Ethereum security model than they trust their local security model. Whereas in other cases, think of, for example, in Berlin, some businesses might trust more the Berlin security model over the one from current one that is a little bit fuzzy, where I think it's a pseudo front end to like Visa, MasterCard, and then a bunch of financial institutions. Actually, Namada is a first fractal instance of Anoma. So you can think of it as another layer 1. It should show you that over time, there's going to be different fractal instances. Some of them might specialize and then pursue different paths to Anoma. But it is just a stepping stone to this multi-chain world of homogeneous architecture and heterogeneous security.
Cool. Nice. So thanks so much for sharing this sort of like breakdown of the differences and sort of the general landscape. There's always a lot of work coming from the Anoma crowd and crew. So I hope this helped people also to understand where those different pieces live and how they work together, and what we're going to already see with Namada and what we are still waiting for with Anoma. Do you have anything else you want to maybe share with the audience? I know that there's like possibly a trusted setup coming or something.
Oh, right. Actually, there are a few things I can share with regards to Namada, which is the most immediate thing, is that we're going to do a trusted setup. It's just because the MSP needs its own parameters. And there will be announcements coming up soon. And then we'll also be doing public testnets as well. So watch out for those. And with Anoma, I'm pretty excited to start seeing next year some first testnets that kind of show you like really the overall architecture transparent way with like a few applications. And then it will really demonstrate, it will allow you to kind of imagine what are the differences in application Anoma and how do they benefit from this overall architecture that is so different.
Cool. All right. Well, thank you so much, Awa, for coming on the show and sharing with us all of this.
Thanks so much for having me.
I want to say thank you to the ZK podcast team, Tanya, Rachel, and Henrik, and to our listeners. Thanks for listening.